What does the air you breathe have in common with the water you drink, or even the phone in your hand? Well, they're all managed by this kind of hidden network of systems. And in this explainer, we're going to pull back the curtain on the incredible field that's dedicated to designing that network for our planet's survival, environmental engineering.
All right, let's jump right in. We're going to start with the basics, our planet's foundation. Then, we'll look at our connection to it, explore how engineering actually provides the solutions, and finally, we'll get a real sense of the mission of an environmental engineer.
First things first. Before we can even begin to talk about fixing problems, we have to get a handle on the stage where everything happens, the environment itself.
So when we say the word environment, it's really easy to just picture, forests and oceans. But it's so much more fundamental than that. It is the entire interactive system, all the living and the non-living things that makes life on Earth even possible. And here are the system's two core building blocks. You've got the biotic, that's all the living stuff like plants and animals, and the abiotic, which is the non-living stuff like air and water. And that constant delicate dance between these two, that's precisely what environmental engineers work to balance and protect.
Now, these components aren't just scattered around randomly, they're actually organized into these distinct but deeply interconnected systems that we often call spheres. You can almost think of them like the integrated systems of a really complex machine, where if one gear moves, it affects all the others.
Okay, so first up is the atmosphere. It's not just one big blanket of air. It's actually 5 distinct layers, and each one presents its own unique engineering challenges. Down here in the troposphere, we're dealing with things like smog and air quality. But way up in the stratosphere, that's where engineers help solve the whole ozone depletion crisis.
Now here's something that might actually surprise you. Take a deep breath. What's in that air? Well, it's not mostly oxygen. A whopping 78% of it is nitrogen. The oxygen that we actually need to survive, that makes up just about a fifth of it. Pretty wild, right?
All right, let's move on to the hydrosphere. That's all of Earth's water. And water is on this constant, incredible journey called the hydrologic cycle. It evaporates from oceans, it forms clouds, it falls back down as rain, and then it collects in rivers or soaks into the ground, ready to start the whole process all over again. It's basically nature's ultimate recycling program. And here is a number that really shapes modern engineering. A staggering 97% of all the water on Earth is salt water. This is exactly why fields like desalination, water purification, and conservation aren't just important, they are absolutely critical to our survival.
Okay, so we've got the planetary systems down. Now let's bring in the main character in this whole story, us. And our relationship with the environment, well, it's a very complex two-way street.
So the thing that's absolutely essential to understand here is that this is a feedback loop. We don't just do things to the environment. It acts right back on us. The actions we take create consequences that directly shape our health, our economy, and our future. So on one side of this feedback loop, you have our impact. We pollute, we clear forests to build our world, and our constant need for energy is driving climate change. These are the problems we're actively creating.
And here's the other side of the street, the direct feedback. That air pollution, it leads to respiratory problems. Those changes in climate, they cause droughts that hammer our food supply. Those rising sea levels can displace entire communities. The connection is direct, and it's undeniable.
So this complex, back-and-forth interaction brings us to the main event. Now that we've identified the problems, let's introduce the heroes of our story, the environmental engineers, the people who are actually working on the solutions.
So what even is environmental engineering? Well, this is where science really gets its hands dirty. It's the practical application of biology, chemistry, and physics to solve our absolute toughest environmental challenges, and really to engineer a more resilient future. Take water management, for example, one of their most critical jobs. They don't just build simple filters. No, they design these incredibly complex systems that can remove microscopic pollutants from our drinking water and even use bacteria to break down waste before it's ever returned to the environment.
They also tackle air quality, and this means inventing technologies that do amazing things, like the catalytic converters in our cars that transform toxic gases into harmless ones, or huge industrial scrubbers that literally capture pollutants before they can even reach the atmosphere.
And what about all our trash? Well, environmental engineers are completely changing the game from just simple disposal to resource recovery. They are the masterminds behind systems that don't just bury our waste, but can safely mine it for energy and raw materials.
So what does a career as an environmental engineer actually look like on a day-to-day basis? Let me tell you, it's so much more than just one single job.
Their mission is just incredibly diverse. I mean, one day an engineer might be in the office designing a brand new water treatment plant. The very next day, they could be out in the field planning the cleanup of a contaminated industrial site, or even working directly with the government to help write the environmental regulations that protect all of us.
Ultimately, what environmental engineering gives us is agency. It moves us beyond just pointing out problems and actually empowers us to build the tools for a truly sustainable future. This is the pathway forward. So, I'll just leave you with this question. Looking at our planet's complex systems, where do you think our engineering ingenuity is needed most urgently right now?